Hello. So, if you haven't watched my video on JavaScript best practices architecture, go ahead and watch that first. This is a workshop based on that. Um, so, I'm going to go through a task just to showcase the importance of architecture. So, for this workshop, we want to build three components which are scalable. And we're not going to write any code. It's all going to be architecture on a piece of paper. And hopefully at the end of this, you will find out how important architecture can be and how it can help you when you want to scale a project. So what are the requirements? Three components. Table needs to be created, sortable table, and a button. They all must have the following methods. They need to have show, hide, and destroy. So every single component must contain these. The other requirements are that table needs to contain rows, columns, cells, and a header row. Sortable table is the same as table, but with sortable header rows. So essentially, header rows that when you click them, they change the data set. And the final one, well, button will not have anything in it apart from the three methods we mentioned in the earlier slide. So what the task is, we're going to draw a class diagram, which is a type of UML diagram of the components that we're going to build. So what is a class diagram? A class diagram, you draw links between the level of inheritance. So you show that car inherits from vehicle. You then show the links between other classes. And what I mean by that is if a car, you want to break it up into a body as a different class or as a driver as another class, you want to show the links between them. If car requires driver class to either use as an instance or create some kind of method that utilizes driver, you need to show that. Then you want to write methods for each of the classes. So this is optional, but what people do is you have the class in a box. So something like car, underneath it you'll have something like wheels, doors, speed as a function or something like that. So you kind of list them down. And by doing these kind of things, especially writing methods, you will kind of see where you need to break out the classes into subclasses, or if you need to create some type of class to work with. So here's some examples of class diagrams. The one on the left is very simple. Dog and cat inherit from mammal. The arrows show the inheritance. German Shepherd and Poodle inherit from dog. And you can see that they've listed out certain variables that are going to be in each of the classes. Mammal has eye color, and dog and cat will inherit that. So you don't need to write that again for dog and cat. And dog has bark, for example, so it has its own one. On the right, we have another one. I wanted to show that this is the same kind of thing with order, special order, and normal order. Normal order and special order are inheriting from the superclass order, but order requires customer, and customer requires order. So you can see that kind of linkage there. That's why there's a line between them. So what I want you to do is grab a piece of paper and pen, take the requirements from the previous slides, and take around 10 minutes, don't take any longer, and start to write out the three components and try and build it on a piece of paper. And then come back, pause the video and come back and we'll go through it. Right. So hopefully you've now done done the task on a piece of paper. You've got something there. Let's go through it. So what did you learn? I guess what you've learned here is that the relationship between classes. So you probably saw that table and sort table is has a relationship because one inherits from another. Potentially, you probably found that there are also other relationships between classes that you've created. So then now you've learned about the relationships between all of your classes that you're going to create, and maybe you've ironed out some issues that you might have not foreseen if you just went into developing without actually doing your architecture. Commonalities between classes. So you know, one of the requirements was they will have to have the same three methods. Maybe you create some kind of subclass to group them all up, or a superclass. Um, so then there's the commonalities between them. You might find commonalities between other classes you've created. Um, Table and sort table also have commonalities because they're both tables. So you would find these commonalities on when you're writing it, and then identify, well, hang a minute, I've got a lot of duplicated code. Maybe I need to do something there. Classes which you didn't think about before. So you might have thought in your head, okay, this is how I'm going to build it. But when you start writing it on a piece of paper and then it starts to come out, things get highlighted and you realize, oh, actually, I need this class, I need that class. And eventually you have a better picture of what your application is going to be like and how to develop it to make it scalable. And you've probably learned new classes, like a superclass, to gather all the common methods. So there's a lot of learning that you do when you're doing something like this, and you'll be surprised. You'll be surprised that the amount of stuff that you've come across that you wouldn't have thought about if you was developing. So let's now think about how essentially people. This is a basic example of people how people would build without a class diagram. Not everybody will do this, but this is a very simple example. They'll create three different components: a table, sort table, and a button. They'll add the functionality hide, show, destroy in each one of them. They'll have in table. They have a table header row, and sortable table will have sortable table header row, and then they'll have some data sets with columns, rows, and cells, and so forth. Again, when you write on a piece of paper, you can see where the problem is. You can see there's plenty of duplicated code, and essentially there's a problem because you can solve it. You can remove all that duplicated code. It's better for architecture. And to be honest, this method is not scalable. If you want to create a new component like a carousel, you're going to have to dump it on the right hand side and create a completely new object, a class, and you can't really inherit from anything else. So maintenance is a nightmare as well. So here's a good example of a class diagram. It's not obviously, again, not much time spent on it. You can make it even better, much more methods, and you can break things down even better than this. But this will give you an idea of the level and see if what you've done is similar to what a good example of a class diagram is. So here I've used an interface. So let's start from the top. An iComponent interface has show, hide, and destroy methods, completely blank methods, and then component inherits from that. So if you look at the key on the left hand side, inheritance is the blue arrow with the actual arrow, and the lines are just links between classes. So component inherits from iComponent, provides the functionality for show, hide, and destroy, and then button inherits from that. And you see it doesn't have anything else in there because it doesn't need to. But obviously, in a real life scenario, you might have some stuff in there. Then table inherits from component. It has a few methods in there: create row header, populate table, create row. And from that, you can see that you need a header row. You're going to need a row to populate this table. So the first thing you see, there's a link between header row and table. Header row doesn't really have anything in there. It may have some other functionality. This is just for a simple example. So header row doesn't have anything in there, but it inherits from row, which has create columns. Then that also has a link between columns, which has create cell, which has a link between cell. So cells are generated into columns in a column, and a column is then required for a row. So there is one-to-many relationships going on there. And then header row has a link between header column, and header column has a link between header row or header cell. Sorry. So these links essentially are exactly the same as row, but header column and header cell might be slightly different to their superclass. So the table is now generated. It has rows, it has columns, it has cells, it has header row, all of these kind of classes. And you can see how you can create new rows very quickly. You can just create a header row, and what we're coming to now is a sortable header row, and you can create multiple columns. So all of these can then be used for a component, or to swap out things in a component that already exists. And everything's nicely and loosely coupled. So then table is inherited, and sortable table is created, which has a method create header row, which overrides tables create header row function. Don't need to do this. It's just to show you that these things can be written in a class diagram. And of course, it has a link between sortable header row, because we want to sort the header rows in here. And there's a method in there called onSort. Essentially, it will just sort the table. So from this, you can see it's quite a big nest. It can look messy to you, but you have your whole architecture here, and you can grow it very quickly and expand it, because everything's very loosely coupled, and everything can be inherited. So when you create this, you know what to build, and you can build this quickly in code. And then if somebody else comes into your project, you can also show them this, and they'll understand how it works, and they can also get involved. You can separate the work between multiple people, because things are isolated. Someone can build the table because you've already got the component aspect of it. Someone else can build rows. It's very, very easy to break out and split it into a team. So hopefully this gives you an idea of how powerful class diagrams are. You've done this on a piece of paper. You feel probably like, it's easier to visualize now your project, rather than starting to code straight away and trying to figure things out. That's it for this workshop. Hopefully you enjoyed it, and subscribe to my YouTube channel if you haven't done so. I do a lot of tech stuff, and I do a lot of JavaScript stuff on there. And hopefully see you soon in another JavaScript session or workshop. Thanks. Bye.